Alright, so I wanted to go over this idea of phase shifts. Phase shifts are just a fancy word for horizontal shifts. Okay, how will you know that there is a horizontal or phase shift? It's pretty easy. All you have to do is look for the parentheses. Class, what are you looking for? And once you know there's a parentheses, you know there's a horizontal shift. Let me show you where there are no horizontal shifts. You just look at your previous examples that we've done. There is no parentheses, there is no C value, there is no phase shift. No parentheses, no phase shift. So we've been focusing on the A and the B values. There is your vertical dilation. This is your horizontal dilation, and inside is your C value. The C value tells us about your horizontal shifts or translations. If here C is greater than 0, you're actually going to go to the right because it would read something like x minus 5. Okay. Now, if C is less than 0 just means a negative number. For example, if I have C is negative 2, this would read minus negative 2, and then we would just simplify that as x plus 2. You would go left or west. So I do have a silly phrase. Add to y, go high. So we're eventually going to learn that's the letter D. If you cover all of that up, there's the plus D. You're just adding to y. You're going to move up or down. Add to x, go west. Now let me show you where that phrase comes from. It's not just a phrase. So let me make up a problem. Something we know a little bit more easier is maybe something like x plus 3 squared. This is just a quadratic. There is a horizontal shift because you have parentheses. I know that because inside I have a number. And in the formula, it's very difficult for students, but it has a minus sign. Class, what does the formula have? So let's write it as a minus sign. Look. Minus negative 3. You see that? Why do I want to know that? Because then it tells me that my C value is actually a negative. So in this case, C is equal to negative 3. Now let me explain to you or show to you what it looks like on a graph. So here's the parent function. We'll call it g of x equals x squared. 1, 1, 1, 1. 2 squared is what? 4. So this is what your parent function looks like. But here, on our silly phrase, add to x, so you're adding here, you're actually going to go west. So I'm trying to show you where this trick comes from. My new graph is actually going to be over here. Well, how did I do that? Think about it. Here, what value would I have to put here to get 0? What value would I have to put there? I would have to put in negative 3. Negative 3 plus 3 is, and 0 squared is. Why did I make y equal x value negative 3, and why did I want my y value to be 0? It gives me the x-intercept. And this clearly shows you that if I put in negative 3 for x, or basically you could put a y value 0 and just solve for x, you get an x-intercept of negative 3, 0, and this explains why it's moving over. Do you see that? So you're going from a horizontal shift left 3 units. So in today's lesson, you have to have this minus sign. If you ever see a plus sign, just write it as the opposite of a negative number. And this is my introduction to horizontal phase shifts for trig graphs.